Hey, happy post-Super Bowl people. It's me, Mr. Cheney, with another brilliant tutorial. It's time to get back to chemistry, and we were doing energy transfers and conservation of mass and energy using the PhET lab energy skate park. So the first video, 10 minutes, I know it was long, but we got through about a little more than half of it, and this is going to be the second part to get us through the entire exercise. We were using this app or website called Pocket Lab Notebook, which kind of consolidated all of our activities into one spot, which I think is nice. And this is going to kind of walk you through the second part of that Pocket Lab PhET experience. So let's get into it. You'll be clicking on that using your Google credentials to get in, and this is my student looking thing, and we've already answered this question. You've made sure that you put the answer into this respond. You have designed your skate park, right? For the trials that we did trials 8, 7, 6, 5, 4, 3, 2, 1. And this table right here has been filled out. So we have kinetic energy at the bottom, we have the velocity or speed, and then at the bottom where there was 0 height, the mass never changed, so mass was 60 kilograms the entire time. And then we had to calculate the gravity potential energy at the top, so we were using the measuring for both. So now we're going to do the scatter plot, and it's going to kind of do it for us. We just have to plug in the numbers. So our heights will remain the same, and we just have to put these numbers in. And I don't think there's really an easy way to copy paste because it doesn't let you just get that one column. So we got to go in here and put all of these values in so that we can get our scatter plot in place. Okay, so now that we have all of our numbers in place, we need to label our data. So the bottom data corresponds to the height of the track, so we'll put this as height in meters, and our y-axis is going to be our kinetic energy in joules. That way we have a labeled deal, and it's quite evident that the higher up on the track that you are, the higher your kinetic energy is. So it's a nice linear equation sitting there for you math geeks. So moving on, conclusion, how does the start height of a skater affect the kinetic energy at the bottom? The chart says it all. So you're going to click this respond button and in your own words kind of tell us what we're seeing with that data, and then see if you can figure out how this is also explaining the law of energy conservation that we discussed. Now, how does the mass of the skater affect the kinetic energy of the skater? So you're going to design an experiment to show how the skater's mass affects the kinetic energy. So hopefully on yours this shows up. I put a chart right here, and if it doesn't, I'll attach that to the Google Classroom assignment as well. Read what the difference is for an independent and a dependent variable in the experiment, and you're going to be actually explaining and identifying what those are going to be, and then going and doing your experiment. So if you go back, what it's telling us to do is actually make a track, and then here's the important part. To include a screenshot of your experimental setup once you've got it set up. So we'll go back up to our skate park, and really we can keep the same track. So I'm just going to keep the same track. You can totally make it different if you want, and the only difference is we're going to go with different masses. So on our table they're only really asking for 5, I think. 3, 4, 5. So I'm going to pick kind of 2 on the low end, then I'm going to pick 1 in the middle, and then I'm going to pick 2 on the high end. So let's see, let's maximize this. And oh, that's not what I wanted. That was gravity. Don't want to mess with gravity. Okay, so let's go with 10 kilograms. And then we'll go with 20, and then we'll go with 190, go put those in our chart. This is just setting up our experiment for how mass affects. And let's go right here, and we'll go 10, 20, 50, 90, 100. And then we're going to calculate, well, actually we'll just measure it this time at the very end with our measuring. So we won't have to do any calculations on this one. So let's run our trials. So we're going to go back up, and we are going to start with 10. And we'll put, let's just go 8 every time. So from the top. And we're going to use our measuring. We're going to go find the zero height, which is right there. And we can see that our kinetic energy at the bottom was 778.8. Okay. Here. 778.8. We're going to run that trial. We're going to run that trial for the next masses as well. So the next one was 20. Start our skater, we'll change this to 20 kilograms, and we'll run, pause, and measure at the very bottom. Okay, we've got 1557.7. Now we're going to measure the next 3. Okay, so we've got our plots for all 5 mass changes, 10, 20, 50, 90, and 100 kilograms. And we have our plots now, and we just have to label our data set. So the y-axis is, again, kinetic energy, joules. And our x-axis is going to be our mass in grams. Now that we have a data set, we want to make sure that we take a picture. We're doing a screenshot of our experiment showing the change in mass. So you can do that with snipping tool, or you can do that with any other screen capture. So Shift-Alt-S I think works for you guys in Windows. So I'm going to take this screenshot right here. You have to save it as a file. So we'll call it Energy Park 2, and if I go to my student, am I on my student one? Yes. Over here, we're going to answer the question. So this is where they want the screenshot shot. So you're answering the question. Let's put the screenshot in this question right here. So you're talking about the results right here. So that's where we'll put our track. How does the mass of the skater affect the kinetic energy at the bottom? So you're just talking about what the results look like in that data set, and then you're going to add your skate park as well. It is. Just have to calculate on these. So a model train, they give you the weight, they give you how fast it's going. You know how to calculate kinetic energy now, so you're going to use this equation to do that, and we're going to give an answer. Your response right there, and that's part 2. That's it. That's the entire experiment. We've done the skate park once you've done both of those. If you have any questions in class, I will be there to help. I'll see you back in class.